No, let this be the height h. Okay, liquid here. So I think everything is same. The only thing is now pressure is P1. P2 is P0 plus rho GH. So look at now V2. V2 will be less than V1. V2 will be less than V1. So I'm interested in V1. I have to make a lot of changes. Huh? V2 I should eliminate. No? Yeah. V1 square, V2 should be eliminated. No? So A1 V1. A2 should be eliminated. So A1 V1 by A2. Yeah, okay, fine. So this will be A1 this one. So here this will become V1. Okay, now you write pressure rate 2 will be more than 1. No? So we'll rewrite this one. V2 will be less than V1. So if I rewrite this, P2 minus P1 should be equal to rho by 2, A2 square, A1 square by A1 square, V1 square. No, P2 is how much due to this P0 plus rho GH. If you want, you can measure this H directly from here. It doesn't matter. And the pressure at this point is P0 exposed to atmosphere. So P2 minus P1, how much it should be equal to? Rho GH. So this will be rho by 2. A2 square, A1 square by A1 square into V1 square. So what is V1 is equal to? 2GH A1 square by A2 square minus A1 square. So can you measure H? As I know H, to what level the liquid will rise here? Fine. Then what happened? I'm able to measure the speed of the liquid. So like what actually it is? So like okay, fine, you wrote Bernoullis, then what actually it is? Suppose if a river is flowing, I'll just tell you. A2 square, it should be, yeah. So everything fine here. So what we get is like how to use this. What is the use of that one? Suppose if a river is flowing here, please, I think in books they don't help to this extent. So just make observation. If a river is flowing, if there's a river is flowing, we'll agree this, there's the surface of the river. So what I do is like the river is flowing with a velocity, say V1. I will dip this venturimeter. Just I'll dip it here. Will agree this? This will be best way of understanding this concept. So what is the meaning of this? Then what will happen? The liquid, this liquid will rise to certain height. Everywhere liquid is there. Huh? Everywhere liquid is there. Everywhere liquid. This equipment is dipped into the flowing river. Will come like this. So what I can do? I can measure this H. And with what speed the river was flowing here, with what speed the river is flowing, with the same speed it will enter. And the same liquid when it passes here will have some other speed. And if you check the V2 will be less than V1. Any reason for that from equation of continuity? because A2 greater than A1. So therefore V2 must be less than V1. So when the liquid moves from 1 to 2, which energy got decreased? Kinetic energy got decreased. The decrease in kinetic energy, what it got converted? Increase in pressure energy per unit volume. So therefore the liquid has to rise to certain height, the liquid column. So the liquid in the vertical limb will rise to certain height. So now I want to measure the liquid which is flowing in a river. So what shall I do? I should just immerse this equipment in a flowing river. What is this everything? Flowing river. So therefore, what I measure the speed V, this V will become equal to V1. So what is V? V is the velocity of river. So nice, no? It is the equipment you can see. So beautifully it was designed for us. Anybody know? Just you have to hold it and see in books what happened, we have equipment. How to use, we don't know. That's why we find very difficult. Okay, what actually it is, that one. There's a rough diagram. Just you have to hold it and dip into the liquid. So the river starts flowing here. I'll show like this. Huh? It'll be easy for you. Fine. Able to understand this is? So like this, can you measure H? I think you know A to A1. We know area of cross sections of the tube. And you have to just note down the vertical height of the liquid in the limb or the liquid in the vertical limb. Substitute here, you get the speed. With what speed the river is flowing. So what actually the equipment? Equipment should be such that it should not disturb the river flow. So what is this equipment? I think you can hold in your hand this one. So if you just take equipment which you can hold in hand, can it disturb the river flow? No, it will not disturb. Okay, this is widely used here. Okay, these are some small diagrams, no, which I'm helping you. Completed. So next we'll go for the next condition. And this is about the venturimeter.